I want to talk about a little bit about the Unified Soil Classification System. Just a few notes on that. I want to look at some ways to calculate coefficient of curvature and coefficient of uniformity. And in doing so, we're going to look at a chart, somewhat like a plasticity chart, but this will tell us how to get our particle sizes by the percent passing. And as you can see, I have these 5 conditions which come from coefficients of curvature and have to do with fine-grained soils and the Unified Soil Classification system. So you might make note of these. I think these will be coming up on your test uh, in week 9 or this week, I guess, by the time you see this. So the first one that's mentioned is the fines content of soil. If the fines content of a soil is 50% is greater than 50%, then the soil is fine. That's right out of the unified soil classification system. If the fine content of a soil is less than 50%, then the soil is classified as coarse. So, like in the AASHTO, you will early on be able to tell if you're going to be dealing with fine-grained soils or coarse-grained soils in the unified system. Fine soil is classified with the plasticity chart with known values of liquid limit and plastic limit, where plasticity index, where the plasticity index equals the liquid limit minus the plastic limit. So a coarse soil, this is number 4, a coarse soil is classified with the flow chart, starting with knowledge of the coarse portion being predominantly sand or predominantly gravel. There's some definite uh, divisions between sand, not just coarse, but gravel, sand, and all of that. And we'll get to that in just a second. So the let's see, number 5, it defines content, of course, is less than 5, then it's a fine. And conversely, if the fines content of a coarse soil is greater than 5%, that's of a coarse soil is greater than 5%, then the classification of the fine portion is needed and is performed by the plasticity chart. Using the plasticity chart to classify soil grains, and that's the American Society for Testing and Materials, that's their number there. The system itself, the Unified uh, Soil Classification System, is based on particles that are greater than 3 inch. Using the grain size distribution and the chart and a plasticity of fines and the plasticity of fines, that's what it uses. The 3 major categories for dividing grain size particles are uh, gr greater than coarse, grained soils, and less than 50% passing the number 200 sieve. Greater than fine grained soils and more than 50% passing the number 200 sieve. And then there's organic soils. Greater than coarse would be cobbles and things like that that we don't really classify. So there's some symbols. Organic is like peat, and we don't deal with that for structural foundation kinds of things. There's some symbols, and there's group symbols, and G gravel, sand, M for silt, clay, C for clay, or organic, and PT for peat if you're going to use it. Liquid limit symbols is H designates a high liquid limit greater than 50. Low is a liquid limit that's less than 50. They're calling it gradation symbols, and that sounds right to me. Well graded and poorly graded. Those are symbols. And there's group symbols. I don't know if I have them here or not, but a group symbol would be GW. That'd be well graded gravel, or SW, well graded sand, so forth. This coarse and fine grain soils that we deal with in AASHTO and the unified system. So these are the soils passing the 200 sieve. So if it's less than 50% passing the number, less than 50% passing the number 200 sieve is fine grain. Greater than 50% passing the number 200 sieve is fine grain soils. Less than 50% passing, according to the unified system now, the number 200 sieve is a coarse grain soil. So just as in AASHTO, you will separate fine grains from coarse grains by these two filters or parameters, if you will. And go a little bit further. What else have I got? Here's where the compartments are. If you look at the number 4 sieve, it is 4.75 millimeters. Well, the fine grains are between 19 and 475, 4.75 millimeters. Now that's not very much. The coarse grains are between 75 and 19. That's where they'll stop. The fines will stop at the 475. The cobbles are 300 millimeters, which is not like bigger than a grapefruit maybe, or grapefruit, to 75. And boulders are actually like basketball size and up. So these are the common sieves used in classifying 10, 40. Gives you a size there. Now, I have, this is, to me, this is not the plasticity chart. It is this is a grain size distribution curve, like we talked about plotting early on in here. And we use this curve. Notice on the horizontal axis, it's the grain size in millimeters, and it's on a log scale. A log scale is like you count 1, 2, 3, 4, 5, 6, so forth. And it accounts for the spacing that you would use if you were using log 10 trig functions to and powers like what is it, 10 to the 12th power squared, or scientific notation, that's what it's called, shortcuts. So to calculate this uniformity coefficient and this coefficient or gradation coefficient, we have a formula, and that formula is D60 over D10 for the uniformity, and D30 over D10 times D. I cannot read that, but my book can. I have my book here. Just give me 1 second or 2 seconds. So we have, this should be D. Here, look at the formula. This should be D60, and it is. This should be D10, and it is. And this should be D60 also, and this should be D10. So you got D60 divided by D10 to get your coefficient of uniformity, and you have D 30% passing here squared divided by D 60 times, that's an X, D10. So we have to get numbers to get this particle size. These D's are diameter of particles that are passing, the 60% passing, 10% passing, 60% passing, and 10% passing. We need those particle sizes. You can see this guy's already done it for us, but let's look at how we do it using a grain size distribution curve. So we take, if we want, let's start with the D10, the 10% passing. Let's figure out what that, and it's used in a couple of different places. Let's figure out what the particle size for the 10% passing. So we go over here, we get our straight edge, and we draw a line. We go all the way over till we hit that curve, and then we go down. And according to his calculation, I'd call that a 0.0, that's his 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, and that's what he came up with for the 10.09. So let's go for the 30% passing. Draw your line straight across till you hit the distribution curve, and in this case you would drop down, and we're at D30, that's 30% passing. So this is 0.1, 0.2, let's see, where am I here? I'm at 1, 2, 3, 4, 5, 6, 7, 8. I'm almost at, that's my 10, 9. So I'm almost to 10, so I'm 0.9. Is that point? He's got 0.9, that was back there. So he's got, let me find it there, 0.19. 0.19 for the 30. And that's the, in millimeters, and that's the D30, that's the diameter of that. He came up with 0.41 for the D60. That might be easier to read. Straight across, down to grain size. He's called there, he's just saying D60. So this is 0.01, 0.1, 0.2, no, 0.1, 0.2, 0.3, 0.4941 he's got, so that's close enough. That's the particle size for the 60, and we did the D10.09. So when you calculate this for the uniformity, he got a 4.56. Now, if you go back in the book and start looking for the coefficients and what they mean, I did have some of that written down somewhere, but I don't have it on this page, this video I'm showing you. But when the coefficient of uniformity is a higher number than 1, it's usually a well graded. And even when it gets, the higher it gets, like 10, if this 4.6 were 10, it would even be better graded soil according to the parameters of the coefficient. Now the coefficient of curvature, I don't have those written either that I'm aware of. So I think they're in the class and the course somewhere. If I could find them, I'll get them back to you or post them in one of those announcement deals. Well, that's kind of all I wanted to show you there. But I want you to look over here if you don't know how to read this, because all of this is part of the uniform unified soil classification system. And here's one that I've been working on. Actually, the unified soil classification system, I know I'm not as familiar with it as I am the AASHTO. But most people, like in day-to-day construction for apartment buildings or things like that, will use the unified. The AASHTO is more stringent, and it's mostly for transportation. American State Highway and Transportation officials are that's AASHTO. So this is the one eventually, if you want to look at videos, focus on this. I think you'll use it more in your work in the field for other than highways. So let me see if I can point to it, but I don't have my camera on it. I got to do that. Let's see if I can do that. Yeah. So here is where I was doing this and watching the video, and I was kind of following him along. If you look, we talk a lot about passing, but look at what we were looking at here. When you have, we had to use the information that came from this was from a sieve analysis. So we had 76% retained on the number 200 sieve. That means that 24% was passed. So when you look, I marked on it, so when there's more than 50% of coarse fraction retained on a number 4 sieve, you have a gravel. So more than 50% of coarse fraction retained on the number 4 sieve. Well, the number 4 sieve, I don't know if I have it on here where I used it. This is it right here. So see, the 95% passed on the number 4 sieve, but again, up here it says if you have more than 50% of the coarse fraction retained, you have a gravel. But we didn't have more than 50% of the coarse fraction retained. We only retained 5%, so that immediately ruled us out of the coarse grain land, period. We went over here, and the gravels, again, less than 5% fines. Uh, and this right here was leading us up to the sand, I think. And 24% passing is greater than this. But I don't remember exactly everything, and I don't have all the information where we can calculate it, nor do I have the time. We were able to rule out this and this, and honestly, I don't know why we got this, why this got ruled out right here. We ended up though with, when you come back down here to this 5%, this takes you to sands and things like that. So we ended up with a clay sand as his choice. And I was just kind of following along trying to do what he's doing. But it's not, to, to me, people say it's kind of like the uh, Ashto, but to me the Ashto is simpler. This is confusing to me, and maybe it's just because I'm not used to focusing on retained as much. It could be I'm used to focusing on Ashto's percent passing. Not that this doesn't do that in some cases, but it's a lot of reading here where your coefficient of uniformity is less than 6. Now, we had the information for all this, and I didn't have access to it, but he had calculated, this guy, when I say uh, he does a really good job of this. I believe if I watch it 2 or 3 more times, I'll be a little bit more fluid with it. But you got to have all everything. That's why we calculate these coefficients, is because we use them in this soil classification. uh, I don't think you'll have a test. I do like your tailgate. There are two videos, and there's one of them's about this guy named Lath. He's a graduate student. It's real quick, but it gives you a sense of the flow better than I'm giving you. And he has his parameters like the percent passing and things all written out for you. But yet you're just not going to get this in this course. We tried to get through the uniform last time and didn't make it. I need to think about what I can take out so that we can focus more on this unified soil deal. But that's all I had for now. Did I did I go over this? If I didn't, I want to. This is comes with the unified soil sheet we was looking at, but this is another way to a part of the classification process. When you get through with all that mess, this has to do with classifying your soil. So if you take a ruler and only got a dozen rulers laying around. If you take a ruler and let's say that you have you have a soil that has a liquid limit of 45, 45, and it has a percent passing, I mean a plasticity index, I'm gonna of 45. I'm just gonna guess 45 right in there. You take your ruler, and this is not like building a watch, and engineers will admit that. But you go across, I'm just going to do it free-handed. 45, if I would go straight across, would put us first. The 40 would put us up here. And if I had a 40, let's call it 40 because I'm going to jump off here. I'm going to call it, we have a plasticity index of 30. So I would come over here and see that would be a plot, and it puts me below the U line. Anything over the U line is you're in upper limits, and you should be suspect of your soil. If I did have 45 and like 45 and we were up here, the soil is automatically suspect. It would need more testing or looking at. So if you have a plasticity index of 20, you would just go all the way across here, and you had a where's 20? I'm gonna go all the way across here, and let's say we have a index liquid limit of 60. Well, that would put us in here, and this is a quadrant. oh, like a quadrant. This is a quadrant. This is a quadrant. These are high, clays with high, or organics with high plasticity, plastic with high plastic, clay with low plastic, organic with low plastic down in here. And way down in here, you get some really funky stuff. Clay with low plasticity and a silt with low plasticity. Over here, you have a silt with high plasticity, and you have an organic silt with low plasticity. But it's a continuation of the work that you do over here. So I'm not saying it's more complicated, but it's more confusing to me than the ashtole. It just takes up doing it over and over again. Uh, would think maybe, if you guys are really serious about moving up in the construction industry, you'd make a good hand and you'll move up. But if you want to really get into things, look at some of these videos. There's some really good ones out there. And know how to slow a YouTube video down. If there's a little gear wheel on all those YouTube videos where you can slow the guy talking if he's talking too fast down. That's all I have for now. I don't know if we'll have another one before you get into your finals. If I come up with something else, I'll post it, like those coefficient of curvature parameters that I was talking about a while ago. But uh, maybe I'll try to come up with some more things that you might. Maybe I'll make a little study guide for the final. We'll see. See what I can come up with. Have a good weekend.